So yeah, let's start with the first sum, structural model. A company choose current asset are worth 40 million. So basically your current asset F0 is worth 40 million. Okay. Then it has basically two liabilities, 20 million after the first year. So basically liability 1 would be your 20 million and your liability 2 would be basically 10 million. Okay. If the company cannot pay its first liability in full, then it will cease to trade. So basically अगर उसके पास 20 मिलियन से कम हुआ तो फिर it won't basically go ahead with the trade. Okay, it will stop. The volatility of the asset is assumed to be 35%. So basically sigma is given as 35%. Cool. And the continuous risk-free rate is 2%. So your R is 2%. Cool. You have been given to assume the company's total asset between the liability follow a geometric motion. तो geometric motion का formula already दिया हुआ है. Okay. Calculate the spreadsheet. Calculate a spreadsheet to simulate 1,500 possible values just after the payment of your liability 1. So liability 1 क्या है? 20 million. We have to create a spreadsheet. Okay. Of your 1500 samples. So basically 1500 simulation we'll draw. Okay, I will just use my fill series. Fill down, sorry, fill series column stop value would be 1500. Okay. Now basically we'll calculate F1. So F1 के लिए क्या होगा? Your T would be equal to 1. Okay, I'm just writing it down here, though we do not need. Okay, your T would be equal to 1 for your F1 calculation. Okay, and basically your Fs would be where S is equal to 0. So we are simulating for that value. So basically F0. So F0, Fs matlab F0. Okay, I'll fix this. Multiplied by e raised to minus r minus half sigma square. So e raised to r means your risk-free rate minus 0.5 into sigma square is 0.5 into sigma square. Okay, into t minus s. So t is equal to 1, s is equal to 0. So 1 minus 0 is 1. So this would be multiplied by 1. Okay. Now sigma plus sigma. This would be W1 minus W0, which is nothing but dW1. Okay. So you'll use directly norm dot s dot distribution, or you can use norm inverse. Okay. Probability would be random value. Mean would be 0. Standard deviation basically dt होता है, तो यहाँ पे dt क्या है? 1 minus 0, so basically 1. So basically it would be square root of your 1. Okay. So you will get this answer 43. I'll just drag it down for 1500 simulation. Let's check everything is working as expected. देखो everything is working as expected. Okay. Now we will calculate the values just after the payment. Okay. So F1 plus. So basically here this indicates that the value of your basically the share price just after 1. Okay. So हम लोग को this would be nothing but maximum of this minus your liability 1. Right. हम लोग ने first liability pay कर लिया उसके related. Okay. This comma 0. Okay. Whatever is higher. तो ये खाली drag down कर लेता हूँ. So if you see there are certain zero values now, this is because your fund value is less than 20 million. तो पूरा तुम लोग पे नहीं कर पाए, therefore ये issue आ गया. Okay. Cool. यहाँ तक समझा? Now For each simulation, determine a possible value just after the payment of the second record. Same मतलब F2 calculate करना है just after the second record. So basically, now what fund value will you have? You will have nothing but this fund value. So basically, you're calculating for t equal to 2 and s is equal to 1 plus. So basically, ये जो होगा would be your fund after your payment has been made. This would be F2. Okay, everything remains as it is. So मैं ये खाली copy paste कर लेता हूँ. I'll just copy paste the formula and amend the formula here only. Okay. तो देख लेते हैं एक बार formula. Okay, this would be nothing but now it would be F1 plus into everything same. Okay, nothing changes because if you see R minus 0.5 sigma square T minus T, so 1 2 minus 1 is 1. Similarly into sigma, basically WT minus WS, so WT minus WS is DWT minus S, which is 2 minus 1. Okay, which would be nothing but norm inverse rad 0 comma square root of 1. Okay, तो ये आ गया 43. Okay, so basically this is your F2. I will just drag it down and I will calculate F2 plus, that is your payment after your basically the thing has been done. Okay, so after paying the first liability, this would be nothing but maximum of this minus your liability 2 or 0. Okay, I will just drag it down. Okay, so you got your value for your simulation. Determine the possible values of payment of your second liability. Use the results in part 2 to calculate the risk neutral default probability. So basically, I have to calculate my default probabilities. Okay, so default probability. So basically, when would default occur? Basically, जब यहाँ पे 0 होगा तब default would happen. This is because your fund value was less than your payment, therefore 0 आया ना. So we'll just count all your 0 values. Okay, so let us just count all your zeros value. Count. Oh, sorry, it would be count if. My bad. Count if where this is equal to 0. So you will get the number of zeros you got. Okay, your default probability would be nothing but this divided by total number of simulation. Okay, so it would be nothing but 26% around. Okay, ये percentage में लिख लेता हूँ मैं. Cool. You got your answer for this one. Easy, right? समझा यहाँ तक? Okay, so let's move ahead. Modify the spreadsheet to calculate the risk neutral probability of default if both liabilities are due after 2 years. So basically, now we have only one liability, which would be nothing but basically this plus this, 20 plus 10 million, which would be paid after 2 million. Okay, so let us calculate all our values. मैं खाली ये दो copy paste कर लेता हूँ. So I will just amend here only. Okay, I do not have to change each and everything. So if you see, B2 is F0 e raised to R minus 0.5 sigma square into T minus S. So now basically your T would be 2. Okay, so T would be equal to 2 and your S would be equal to 0. Yeah, perfect. So you will get the value of F2, that is the fund value at time 2. So basically this would be nothing but multiplied by 2 now because it is T minus S. And now WT minus WS, so DWT would be basically nothing but this would be nothing but square root of 2 now. Okay, because you are calculating it for the 2 time period, everything remains as it is. Okay, I will just drag this down. Okay, now I will calculate F2 plus. okay, which is your fund value after your liability has been paid. So which would be nothing but maximum of this minus basically your liability or 0, whichever is maximum. Okay. Now we'll calculate your count of 0 and probability of default. So let us calculate it. Uh, just a second, I will just 1510 तक जा रहा है, perfect है. Yeah, 1510 and this would be also ऊपर थोड़ा. Yeah, perfect. So now if you see, basically this was nothing but exactly the same thing ना. Your liability 1 was equal to 20 और फिर 10 million. बट यहाँ पे प्रोबेबिलिटी ऑफ डिफॉल्ट 25% आया. अगर एक साथ पे करने का आया तो मेरा प्रोबेबिलिटी ऑफ डिफॉल्ट 35% हो गया. कैन एनीवन एक्सप्लेन मी विथ लॉजिक व्हाई दिस वुड हैपन?
ये अपना टाइम जैसा है क्या ना, प्रोबेबिलिटी ऑफ डूइंग कि
यू कैन थिंक ऐसे कि देख, यहाँ पहले मेरे को 20 मिलियन पे करना था, फिर मेरे पास एक साल का स्पैन था ना 10 मिलियन और अरेंज करने के
हाँ,
लिए.
सो आई कैन इन्वेस्ट एंड फिर वो मेरे को थोड़ा इंटरेस्ट
हाँ,
आता है, उससे मैं करती तो मेरा इतना
पर यहाँ
प्रोबेबिलिटी ऑफ
पे
डूइंग
एक
नहीं
साथ
आता.
30 मिलियन आ रहा है तो फिर भाई थोड़ा लोचा होगा ना. बेसिकली एक ही डेट पे तेरे को 30 मिलियन आया. व्हाट इफ द फंड वैल्यू इज लेस देन योर 30 मिलियन? तो फिर लोचा आ गया ना. तो एक साथ जब बड़ा
हाँ.
अमाउंट आता है, इट इज डिफिकल्ट टू रियलाइज योर एसेट. देयरफॉर प्रोबेबिलिटी ऑफ डिफॉल्ट अगर थोड़ा बढ़ जाता है. ओके. So with this we are done with our first sum. Let's move on to the next sum. Okay. Just a second. Yeah. So let's move on to our second sum now. Cool. Now your two-state model. Your lambda t has been given with respect to certain formulas. Okay. The the status of a 10-year zero coupon bond is modeled using the two-state with a default intensity at time t. So this is your default intensity. Okay, lambda t is your default intensity. Okay, for time 0 to 10. Okay, describe how the probability of the bond default changes over the life of the bond. Okay, so basically I'm writing my dt to be equal to 1. Okay, मतलब I'm just making my time का difference equal to 1. Okay, nothing new. So 0 to 10 था. Oh sorry. So basically 0 to 10 था. Okay. Now describe how the probability of default would change over the life of the bond. So basically I'll just draw my time t till my time value. Okay. And your default intensity, I'll just write it down. Okay. It is nothing but 1 upon 3 plus t. So 1 upon 3 plus t. Time is 0. Okay. So you can see that my default intensity is basically decreasing as the time decreases, right? So basically, what would happen to probability now? Can anyone tell me?
इंक्रीज होगा.
It would get increased because it has an inverse relation. Okay. So basically यहाँ पे लिखा है probability का formula. It is nothing but e raised to minus lambda t dt. Okay. This is probability of bond surviving. Okay. So probability of default would be 1 minus the same formula, e raised to minus lambda t dt. Okay. So यहाँ पे मैंने कैलकुलेट कर लिया. So you can see, अरे probability negative क्यों आया है? E raised to minus lambda t dt. Sorry, my bad. Okay. So basically this indicates time 9 पे कितना probability हो रहा है. Okay, but basically as your sum basically sum करने जाएगी तो probability is like more. Okay. So this is happening. Now let's read the question ahead. Time can be decreased into non-overlapping time intervals of length dt. The probability of bond not defaulting over a certain time period can be calculated by e raised to minus lambda t dt. Lambda t का formula ये रहा, dt we have as equal to 1. A company issues 10,000 bonds. Assume that the state of any one bond is independent of another bonds. Let dt be equal to 1. Okay, यही हम लोग ने dt equal to 1 ही लिया है. Okay, that this was by fluke. This was basically to make you understand. By fluke हो गया. Okay. Calculate the probability of single default within each time step, assuming that isn't in default at the start of the interval. So this basically indicates ये जो हम लोग ने calculate किया है ना, okay, we have done it. It indicates the probability of default, okay, at the particular time. Okay. So using the probability to part 2, okay, calculate the expected number of bond from original 10,000 that will successfully pay out at maturity. Okay, so basically paying out and default. So at time 0, they said we have 10,000 bonds. Okay, so basically 10,000 bond है. Time 0 तो कुछ default नहीं होगा ना, time 1 पे default होगा. Okay, so this would be basically the number of defaults would be equal to 0 at time 0. At time 1, okay, it would be nothing but the number of bonds you have multiplied by the probability, indicating your default value. Okay, so there are 2,800 bonds have defaulted. So basically the number of bonds, okay, would be nothing but 1,000 minus this at time 1. Itna bond bacha. At time 2, how many bonds have defaulted? The number of bonds at time 1 multiplied by the default probability, and so on. मतलब सबके लिए होगा. Okay? And even your number of bonds at time 1 would be nothing but bond at time 1 minus the number of default. ये drag कर लेता हूँ. Okay, so basically at the end of time 10, okay, we would be only paying 2,000 bonds and 8,000 bond हम लोग ने default कर लिया. Okay, this indicates this. Now in the fourth part, they have told to basically repeat the calculation, okay, in the previous two parts where dt is equal to 0.1 and dt is equal to 0.01. Okay, so what I will do, I will make a copy of this sheet. Sheet 2 ka I will create a copy. Okay, I will write here अपना क्या है 0.1 से start करते हैं. Okay, so dt would be equal to 0.1. Okay, और यहाँ पे I will just change my time. Okay, it would be nothing but I will use my fill series instead. So this fill series, your step value would be 0.1 now and stop value would be same 10 value. Okay, अरे यार, sorry, I had to make it column 0.1 and stop value would be 10. And I will just drag it down. Now पूरा का पूरा I will just drag it down. Nothing else I will do. Okay. खाली ड्रैग कर लिया. ओके, और मेरे को ये आंसर आया. ठीक है, you have to do that much only क्योंकि बाकी सबका formula would be exactly linked to your lambda t. Lambda t would be basically linked to your dt. So everything is directly linked. So you do not have to do anything. Similarly, we'll make again a copy. Okay, we'll make this 0.01 as asked in the question. Okay, so 0.01 कर लेते हैं. And I will again use my fill series and again drag it. Okay, series column, your step value would be now 0.01 and your stop value would be 10. We'll just have to drag it down, nothing else. Got this? Comment on the calculated number of surviving bond compared to the theoretical 2308. Okay. So basically, मैं यहाँ पे minimum निकाल लेता हूँ, which would indicate the number of bonds I have at time 10. सबसे minimum value ही होगा ना. We got our answer to be equal to 2308. Okay. You see that these two are damn close. Okay. So अपना जो ये time discretized time हो रहा है, it is like working approximately true. Let's check for 0.1 क्या हो रहा है. Basically, if you see for 0.1, it is 2278 and theoretical 2308 था. A large difference, right? This is because discrete में हम लोग ने time 0.1 से लिया. So now even if you see, यहाँ पे भी बहुत बड़ा default हो, basically बहुत बड़ा difference होगा as compared to your 0.1. Okay, it would be minimum of this giving you 2012. The answer would be 2038. So you see the difference basically decreases when your discretization, basically your continuous to discrete, is going through an appropriate stage. So अगर ये 0.0001 होता तो ये आंसर और भी क्लोज आता. Basically your answer of this would be equal to 2, 3, 0, 6 or 7 around, making your answer more stable. So जैसे discretize के कारण we are getting a big difference. Okay. So this is your comment with respect to the theoretical part. समझा ये सब? समझा ये सब कि नहीं?
हाँ हाँ समझा.
Easy है ना अभी तक तो?
हाँ.
Okay, so we are done with your second sum. I will just save this file. Okay, I will create a copy of this file. Okay. Question का मैं copy create कर रहा हूँ, nothing else. I will paste it on my desktop instead. Wait. पेस्ट का ऑप्शन ही नहीं है. लॉल. नेवर माइंड, मैं सेव नहीं करूंगा. छोड़ो ना, कौन करेगा मेहनत. It's taking time to open my Excel. Give me a minute. Okay. So basically, let's start reading the question now. Okay. The spreadsheet provider contains the transition probabilities. Okay. So basically, this is the transition probabilities which we have given. How can you see it's a transition probability? Sum is equal to 1. Sum of this all values equal to 1. Okay. So this is your transition probabilities. Calculate the sum of each row of matrix to verify that probability is equal to 1. So मतलब यही sum करना था, which they have already done. So this is like perfect. Okay. Now calculate the probability of a 3-year AA rated bond, keeping its initial rating for 1 year and then moving to A and then to BB. So basically AA is staying AA, then followed by A, then BB. So इसका probability, can anyone tell me the answer?
क्या मतलब क्या ढूंढना क्या?
The probability that मेरा bond starting में A है, AA है, नेक्स्ट ईयर भी ए रहेगा, फिर ए हो जाएगा और फिर बी हो जाएगा।
पता नहीं।
इट वुड बी नथिंग बट ए, एक साल ए रहा, ओके, फिर इट वेंट फ्रॉम ए टू ए एंड देन वेंट इट फ्रॉम ए टू बी। तो ये तीन प्रोबेबिलिटी का मल्टीप्लिकेशन would give you your value।
बस इतना ही करना है।
हाँ,
तो वो फिर वो मल्टी क्या कहते, मैट्रिक्स मल्टीप्लिकेशन का क्या होता था?
ये हम लोग को बेसिकली मैट्रिक्स मल्टीप्लिकेशन वी कैन डू इट, बट ऐसे भी तो सॉल्व कर सकती है।
ठीक
है सो कूल। नाउ this is now your matrix multiplication, okay, you have to matrix multiply for pi 2, okay, so मैं खाली ये copy paste कर लेता हूँ, okay, I will just copy paste this, control C, control V, okay, so basically how to solve for these values, matrix multiplication करना है for, because you are doing it from time 1 to 2, 0 to 2, so 0 to 2, okay, so it would be nothing but ये दो बार multiply करने से मेरे को आंसर आएगा। So let's do it. How to? Similar array लेना है तो array में सब value ले लेने का is equal to m mult. M mult means matrix multiplication. You have to select the whole table twice. Okay, you have to select the whole table twice, and then Control Shift Enter या Control Enter.
कंट्रोल
Control
शिफ्ट।
Shift.
You will get all your values. This indicates your probability
कितना
of for your
मस्त है।
two-year value. हाँ?
हम लोग क्या गधे जैसे, हम लोग कितना मेहनत करते थे पता है मैट्रिक्स मल्टीप्लिकेशन में।
I know that.
इसलिए
Now we are doing from 0 to 3. Okay. ये डिलीट कर लेता हूँ। These वाले और just delete। अरे हाँ ना भाई। How to calculate the values? एक second ना। Default would be basically a sum of the probability should be equal to 1 ना। ये नहीं हो रहा है। So what I will do, I will just put your default probability as 1 minus sum of this, indicating A से default होने का probability. So now basically you will get your sum as equal to 1. Okay. Similarly, we'll do it for this also table. Okay, it would be nothing but m mult, basically 0 to 2 multiplied by 0 to 1, indicating your 0 to 3, right? Array, yeah, Control Shift Enter, you'll basically get all your values. Okay, you have to just यहाँ पे 1 minus करना पड़ेगा to make it sum as equal to 1. Okay, so and see that basically you'll get all your values. Now you could compare this also कि AA BB जाने का probability क्या हो रहा है. Okay, AA BB जाने का probability is 0.042, is basically like saying that 0.05 के around ही है, so like it's approximately the same. Okay, now हो गया this, second and third one is done, m mult 0 to 3 हो गया, 0 to 2 हो गया. Now find the probability that an initial A rated bond defaults after 3 years. So अभी इसका मेरे को probability तो now you can say ना.
ए 3 इयर्स के बाद डिफॉल्ट 0.727।
Yeah, perfect. We'll just link it. बस हो गया. Now for this value.
ये तो यही रहेगा ना 75.05।
05 ना. Yeah, perfect. हो गया.
ये मेरे को लग रहा है हम CH2 में पहुंच गए।
So like with this, okay, we would be done. Okay. और else इसका आंसर है ना, it could be also this also ना, AA का AA रहने का probability raised to 3. So if you see, answer is quite similar, but थोड़ा differentiation है because of your matrix multiplication. both answer which you do is completely right. Okay.
Okay.
So like ये है. Okay. With this, you are done with your chapter 19 solving.